Hello everyone, my name is Anika Babar and today I am going to explain Data Science Assignment 3. So, first question is explain the difference between supervised and unsupervised learning, provide examples of algorithms for each type of learning and discuss scenarios where each would be appropriately used. So, its features are given unsupervised learning and supervised learning and unsupervised learning. So, a learning paradigm where the model is trained on a labeled dataset, meaning the data includes both the input features and the correct output target. Unsupervised learning, a learning paradigm where the model is trained on unlabeled data. The system tries to learn the patterns and structure from the data without any supervision. Next feature is goal to map input variables to an output variable accurately. Now next goal is unsupervised learning to discover underlying structure, groups or patterns in the data. Next feature is feedback. So for supervised learning, direct feedback is provided. Loss is calculated based on the difference between predicted and actual values. Unsupervised learning, no direct feedback. The model self-organizes based on statistical properties. Complexity. Computationally simpler to evaluate performance, accuracy, RMSE. And for unsupervised learning, computationally complex to evaluate as there is no ground truth. Algorithms, linear regression, logistic regression, support vector machines, SVM, decision trees, random forest, neural networks. And for unsupervised, there is k-means clustering, hierarchical clustering, PCA principal, component analysis, a, a priority algorithm. Scenarios: spam detection, classifying emails as spam or not spam based on labeled history. Customer segmentation, grouping customers based on purchasing behavior without predefined labels. Example: house price prediction, predicting price based on size, location, etc. Anomaly detection, finding credit card fraud by identifying unusual patterns. Next question we have, describe the concept of hypothesis space in machine learning. Explain the algorithm. Find find a hypothesis by find S for the following instances. So here we are given uh, a table in which origin is given, manufacturer are given, color, decay, type, and class are given. So the concept of hypothesis space H is in machine learning, the hypothesis space is the set of all possible legal hypothesis rules that the learning algorithm can consider to approximate the target function. If you are trying to classify a car as a positive or negative, the hypothesis space contains all the possible combinations of attribute constraints. Example: origin is equals to Japan and color is equals to question mark, etc. Find S algorithm explanation. Find S, that means find specific, is an algorithm used for concept learning. Its goal is to find the maximally specific hypothesis that fits all the positive examples in the training data. So for this, step 1, initialize the hypothesis H to the most specific value possible, usually all nulls or empty set. Step 2, for each positive training instance X, for each attribute constraint A, I in H. First, if the constraint AI is satisfied by X, do nothing. If AI is not satisfied by X, replace AI in H with the next more general constraint that is satisfied by X, usually replacing specific value with a question mark, representing any. Now step 3, ignore negative instances. Step 4, output the final hypothesis H. Now for solving the problem database analysis, we have 2 points. First, attributes, and second, target. So in attributes, we have origin, manufacturer, color, decade, and type. and target we have class, which is positive and negative. Now process. So in process, first we have initialize h 0. You can see here how we initialize the h0, then we initialize I, that is positive, and then we initialize 2, that is negative. So our instance 1 is positive, instance 2 negative, then again instance 3 positive, then we have instance 4 negative and instance 5 positive. So next question we have, explain the purpose of training, test and validation sets. What is cross validation and how does it differ from a simple train validation test split? So the purpose of data splits are: first training set, second validation set, and third is test set. So in training set, the actual data set used to train the model. The model sees and learns how this data updates, weights, or biases. Validation set, a sample of data held back from training used to tune model hyperparameters like learning rate, K in KNN. It acts as an intermediate check to prevent overfitting during development. Test set. The data set used only once at the very end to provide an unbiased evaluation of the final model fit. It simulates how the model It stimulates how the model will perform in the real world. Now, next we have cross validation versus simple split. So simple train validation test split, you divide data into three static parts. Then its drawback is, if if your specific validation splits happens to be easy or hard, your evaluation will be biased. You waste 20 to 40% of data that is never used for training. Next, we have k-fold cross-validation. In this, we have the data is divided into $k subsets. The model is trained $k times. Each time a different fold is used as the validation set, and the remaining $k and $1 folds are used for training. The final result is the average of all $k runs. Advantage is every data point get to be in the training set and the validation set exactly once. It provides a more robust estimate of model performance and is better for smaller datasets.